Hello and welcome. We will present ResearchX3D, a new collaborative online platform for exploring truthful and scientific research. We will show you how you can discover some of the most ingenious scientific setups from your home, even on your own kitchen table. To start, let's first see, where do these objects come from? Humans evolved to hunt, so we can see, hear, manipulate, and even perceive time only over a limited range. To overcome our limits, we have been building tools. Tools have extended the reach of our influence. Some tools even made us see better the world that surrounds us, by allowing us to precisely describe the natural phenomena, using numbers to quantify what we observe. A number of these tools ended up being in everyday technology, enabling comfortable life and reaching new places. But this is only a part of the story. Thanks to some tools, we discovered that outside the limited range that we can directly perceive, there is a host of exciting new phenomena hiding. These tools are scientific instruments, and they showed us that the world is a much larger and richer place than we ever thought. In ancient Greece, the idea that there exist small indivisible atoms was just one of many philosophical concepts of what the basic constituents of the world could be. Much later, a new scientific instrument, the microscope, allowed the discovery of phenomena that will, only in the 20th century, stimulate the theory how to prove the concept of atoms. In 1908, it was again with the microscope that detailed quantitative evidence for atomic theory was found. This experiment tested an idea against the world we observed and confirmed it. However, when trying to test ideas about the world, we often do not get what we expect. Instead, we discover something new. In the 19th century, when James Clerk Maxwell was developing his electromagnetism theory, he was writing equations to describe waves of electromagnetic origin propagating through space. These waves explain the light we see, as well as how we transfer information over Wi-Fi and the internet. But in Maxwell times, it was unclear what makes these waves propagate. Waves in solids and liquids were familiar, like earthquakes and waves on the sea. So, in analogy, Maxwell was imagining that some sort of mechanical wheels and gears are responsible for electromagnetic waves too. Although no one has seen such gears, most of the people were expecting to find them and to clarify how electromagnetic waves move through even seemingly empty space. People called that unseen medium the ether. It was only at the end of the 19th century that we understood things better. Again, this was thanks to a new scientific apparatus constructed by Michelson and Morley in 1887. This apparatus was capable of detecting minuscule differences in the propagation of light as we move with Earth through the ether. And what they found was unexpected. The apparatus detected no motion of ether, or more precisely, if the motion existed, it would have to be at least 100 times smaller than our expectation. There was practically no trace of that ether. Not only did this firmly establish that electromagnetic waves really move on their own through empty space without an invisible support, but it also provided the key stimulus to then young Albert Einstein to formulate his special theory of relativity. By now you might be persuaded that in the quest for knowledge about the world, the scientific instruments are powerful and indispensable tools. You might start wondering, how does one make a scientific apparatus? To see that, we have to go for a journey. Venice, 17th century. We're following a professor of mathematics from Padua, Galileo Galilei, on his shopping trip. On his shopping list are some unusual items for a math professor. They include cannonballs used by the military, organ pipes used for church music, some glass plates, and a number of powders and raisins. Galileo was making a telescope, but because it was one of the first of its kind, he had to put existing technology into new, unexpected use. He took glass plates and used a round-shaped cannonball to grind the glass, and powders of different finesses to polish the glass into lenses. Organ pipe provided solid support for the telescope. Yet to be successful, this conceptual plan for magnifying distant objects had to be combined with other considerations. Nothing can be made perfect, so to know what are acceptable tolerances in production and how to achieve them is crucial to get a good result. The mechanical properties of selected materials had to be known to ensure that the instrument works under changes of temperature and external forces. Finally, external influences that would add noise to signal had to be reduced to a minimum. Only then are the results satisfying, and Galileo could record his observations. Fast forward 400 years into the future, to the present time, and designing scientific apparatus remains similar. We put existing technology to new use, combining many different knowledge areas. We explore existing technologies, find best ways to combine them, prepare design drawings, manufacture, assemble, and test, often repeating the process many times over until research results are satisfying. In a successful scientific instrument, every detail is the result of many design considerations, combining knowledge contributed by a number of researchers and engineers. But that knowledge is usually incompletely recorded and very hard to discover. Here is an idea how to make this accessible. It starts with your mobile phone. If you know some interesting scientific apparatus, you can easily take a picture with your mobile phone. Actually, not just one, but several, such that each point can be seen from multiple angles. Once you have made such pictures, go to ResearchX3D.com and upload your photographs. Depending on the complexity of the object, it takes 30 to 60 photographs to record all its details. Our platform transforms your photographs into a 3D model of the apparatus that can be easily accessed from any device connected to the internet. So now everyone during a coffee break can record and share with the world some exciting apparatus from their own environment. But that's just the beginning of a new life of the apparatus. It starts with a story. Every object has many stories to tell. You can find them easily in ResearchX3D. You select the object that interests you, and you will get a list of stories about the object. You can filter them according to your knowledge level. Let's see one of the stories about this detector. Together with the object, we see annotations in 3D and textual explanations. Each story has multiple segments with its own annotations and texts, and it can even have graphical or audio descriptions too. If you have questions about the object, you can ask them. For each object, you can see existing questions. When asking and replying, you can use annotations in the 3D space to point and tell. You can see all of this in augmented reality too. And it is easy to get yourself immersed in augmented reality with technology you have. You just need to download the AR marker from our webpage and print it. Put the marker on your desk and turn on the AR in the ResearchX3D webpage, and you're ready to explore scientific experiments and stories on your very own desk. Sharing of objects and stories with friends and colleagues is easy. Click on the Share button and you will see different options, with a simple link, with QR code you can print, or even with ready-to-go figure for your printed report. Finally, if you have a story to tell, please contribute. Our online editor allows you to quickly write descriptions and to make annotations. In addition to text, each story segment can also have graphical and audio descriptions. The ResearchX3D platform and selected stories are available in 25 different languages, because scientific heritage is part of our common, shared human history. Contribute your objects and stories, and let's together democratize access to knowledge and inspire others.